Alright Titans, it's Mr. Spilker here. Welcome to Algebra 1, Chapter 10, Section 3. Tonight we will be introducing a new concept to you, and that concept is completing the square. We have two objectives for tonight. The first one is to form a perfect square trinomial from a given quadratic binomial, and the second one is to be able to write a given quadratic function in vertex form. First thing we need to do here tonight is to review a perfect square trinomial. A perfect square trinomial is when the first and third terms are perfect squares, and the middle term is twice the roots of the first and third terms. So down here we have an example of a perfect square trinomial. The first term and the third term are perfect squares, and the middle term is twice the roots. Remember, when we have a perfect square trinomial, it will factor to be two factors that are the exact same. In this case, x squared plus 8x plus 16 factors to be x plus 4 times x plus 4, which a lazy mathematician would go ahead and write that as x plus 4 squared. The first skill we have for you here in Chapter 10, Section 3, is to find the missing term that would make the trinomial below a perfect square trinomial. So in other words, we're going to take a binomial and we're going to turn it into a perfect square trinomial. To do that, we need to use the process of completing the square. That's what I've highlighted down below. To complete the square, what you do is you take the linear term, which in this case is 16, you divide it by 2, which would give you 8, and then you square it. So you take the linear term, the middle term, divide it by 2, and you square it. Then you take that and you add it to the original problem. So 8 squared would be 64. So if this question mark was a 64, guess what x squared plus 16x plus 64 would be? You guessed it, it would be a perfect square trinomial, because the first and the last term are perfect squares, and the middle term is 2 times the roots of the first and third term. So that's our first skill today, the ability to take a binomial and, by completing the square, make it a perfect square trinomial. Let's go ahead and try a couple more examples. Once again, we're asked to take this binomial that's given to us and find the missing third term that would make it a perfect square trinomial. So to do so, it's really quite simple. You take the middle term, you divide it by 2, and you square it. That's called completing the square. So what number belongs on the end? 100. Number 2. Go ahead, take the linear term, divide it by 2, and square it. What number belongs on the end? A 4. As you can see, I've made both of these perfect square trinomials. Now read the directions carefully on your assignment. It may ask you to go ahead and, after you create the perfect square trinomial, factor it. If you do, they're pretty easy to factor. What adds to 20 and multiplies to 100? 10 and 10. What adds to 4 and multiplies to 4? Once again, pretty easy, 2 and 2. Alright, a couple more examples. Here's one where the middle term is negative, and then the second one is one where the middle term's odd. So let's go ahead and do two more examples. Once again, same directions, folks. Go ahead and complete the square. Find the third term that would create a perfect square trinomial. So what you do is you complete the square. You take the middle term, you divide it by 2, and you square it. So what number belongs on the end? 64. Let's say the middle term is an odd number. This sometimes is difficult for students. What's negative 9 divided by 2? Well, negative 9 divided by 2 would be negative 4.5. Okay? And then once again, you take that number and you square it. So we would take negative 4.5 squared, which would be 4.5 times 4.5. And that would give me 20.25. So the number that's missing on the end is 20.25. Remember, in a perfect square trinomial, that last term is always positive. So these missing terms that I'm finding are always positive. And as you can see with completing the square, whenever you take a negative number, divide it by 2, and square it, it will always come out to be positive. So just keep in mind, whenever the middle term is an odd number, you're going to be dealing, for the most part, with a decimal at the end of your perfect square trinomial. Alright, now that we got skill number 1 down, let's go ahead and move on to skill number 2. Once again, these are videos. You can pause them, you can rewind them, you can go at the pace that you need to go at to learn the material. Skill number 2 is to use the complete the square process to write the function in vertex form. So here in skill number 2, we're going to give you a function, meaning y equals x squared plus 6x minus 16, for example. And if you saw one like this, you'd think, oh, I would probably go ahead and try to find the zeros, and then once I find the zeros, I could go ahead and find my line of symmetry and then find the vertex. But students, what if this cannot be factored? Remember, to find the zeros, you have to be able to factor the trinomial. So wonder if you run into a trinomial that cannot be factored. Well, then you would want to use the completing the square process. So if you go ahead and you take a look at this function can't be factored. There's nothing that multiplies to 5 and adds to 2. So you cannot use the process of finding the zeros. So what we're going to do is we're going to go ahead and take this function that is in standard form, and we're going to go ahead and change it into vertex form. And you can do this by using the completing the square process. Here's the steps. These would be important for your notes. Step 1, group the first two terms. Step 2, complete the square after grouping the first two terms. And that should say step 3 there, you go ahead and the number you use to complete the square gets added on the inside and subtracted on the outside. Then step 4 would be to go ahead and factor your perfect square trinomial. Step 5 would be to write it in vertex form. And then your last step, step 6, would be to name the vertex. So let's go ahead and use the one on the slide here as example number 1. Let's say we had y equals x squared plus 2x plus 5. Now we can go ahead and easily get that to be in vertex form. And remember, vertex form is the easy form to graph in. What you do is you take the first two terms and you group them together. Then with those two terms you complete the square. So if I were to complete the square, I would go ahead and take my linear term, which is a 2, divide it by 2 to get 1 and square it. And 2 divided by 2 is 1, and 1 squared is just plain old 1. So what number completes the square? 1. So I add that on the inside, and on the outside, guess what I do? Subtract it. So I know it's getting a little messy down there in the right-hand corner, but I would add 1 on the inside, subtract 1 on the outside. Now, that trinomial that's in the parentheses is a perfect square trinomial. So I can factor that to be x plus 1 squared. And on the outside, 5 minus 1 would be 4. And as you can see, I now have my function in vertex form, and it can be easily graphed. So make sure you have those steps down in your notes, Titans. That's something we'll be looking for as we check notes tomorrow. Alright, Titans, one more example to finish the night off, and that is to write this function in vertex form. So we're going to go ahead and use the completing the square process to put this in vertex form. So I'm going to go ahead and group my first two terms together. After grouping my first two terms together, I'm going to go ahead and use the completing the square process. So I'm going to go ahead and figure out what number completes the square. So I take my linear term, which is -4, I divide it by 2, and then I square it. And -2 squared is what? Yep, 4. So I add it on the inside, I subtract it on the outside. Then you factor your trinomial. This trinomial would factor to be x minus 2 times x minus 2. And on the outside I can combine 3 and -4 to make -1. And then this can be further simplified because x minus 2 times x minus 2 would be x minus 2 squared. Now my function is in vertex form. That is writing a function in vertex form by using the completing the square process. Alright, Titans, just remember to complete the square, you take the linear term, you divide it by 2, and you square it. That's a key point from this teaching video. Hope you guys enjoyed the video. Have a good night. We look forward to seeing you in class tomorrow and doing some more practice with completing the square.
Made with Doodlecast Pro.